It's recording, so here we go. Hey guys, how's it going? If you're taking the AP test, I'm putting these notes out there for you to make sure that you are prepared. There is also a notes sheet that you can print off, as well as the PDF that kind of gives a synopsis of what we're doing. I felt this note sheet was a helpful thing. The first thing it talks about is degree. The degree is the highest exponent in a polynomial. There's an example that tells us that 3x to the fourth plus 28x cubed minus 4x squared plus 6x minus 12 has a degree of 4 because of the x to the fourth. What we're going to be talking about today, and what these notes are based off of, is finding horizontal and vertical asymptotes. The vertical asymptote is always found by deciding when the denominator is equal to 0. Every single problem, I want to know when is the denominator equal to 0. That is going to be my vertical asymptote. Every single time. Set the denominator equal to 0, solve for x. That's my vertical asymptote. Every single time. I don't care what anything else looks like. That's how I find my vertical asymptote. The majority of these notes are going to now be talking about how do I decide what the horizontal asymptote is, how many horizontal asymptotes I might have, and so on and so forth. So, let's first start off with the first example. Example 1. I'm starting off with the most generic form of this, of these general rational functions. Yes, I can have more terms than just the leading terms, but I want to look at the leading terms because the leading terms tell me what's going to happen. When I look at this, I want to look at my leading coefficient for the numerator and the denominator. For each of these, I have 3 possibilities. My numerator, the top number, is larger than the bottom number, the denominator. They're the same, or the top number is smaller than the bottom number. We're going to look at these 3 cases and go from there. So, for the first one, my m is less than my n. So it's a problem like this one here, where my degree on the bottom is 2, my degree on the top is 0. 2 is definitely larger than 0. If I had a problem that was 3x cubed plus 2x squared plus 7x plus 6 over 5x to the fourth plus 2x to the third plus 7x squared plus 3x plus 9, I would still look at the same thing and see that my leading coefficient, the bottom one, the denominator, is larger, and I would use these rules that we're going to talk about on this slide. So, if m is less than n, the line y equals 0 is a horizontal asymptote. The vertical asymptote is located where the denominator is equal to 0. As in last night's homework, there can be a plus k that will shift this y possibly up or down. So if I'm looking on the paper notes that I gave you, this is the letter B in the middle, where the degree of the top one is less than the degree on the denominator, the bottom. If I have a plus k, that's also going to just shift from y equals 0. But since here I don't have a plus k, I know that I have an horizontal asymptote at y equals 0. My vertical asymptote is when my denominator, that might have been my phone. When my denominator equals 0, so I set my denominator equal to 0, I get x squared equals -1. I square root both, -1, square root both sides. X is equal to the square root of -1, plus or minus. I Please look on the graph and tell me where I is. It's not there. So does this particular problem have a vertical asymptote? No, it does not. Okay? At this point, if I want to see what this graph looks like, all I really do is plug in coordinates, and I find what my x's and my y's are. If I'm able to use my calculator, I can plug it into my calculator and look at the table, and it'll give me points to graph. But I can see it on my calculator. For this particular problem, since I'm doing this by hand, let's go ahead and plug x and y's to see what this looks like. I'm going to pick x's like -2, -1, 0, 1, and 2. These are the numbers right near the origin. So if I plug this in, I get 4 over -4 squared plus 1. Excuse me, 4 over -2 squared plus 1. So I get 5 in the denominator. So this is 4/5. When I plug in -1, I get 4 over -1 squared plus 1. So that's 4 over 2, which is 2. When I plug in 0, I get 4 over 1, so I have 4. Since this is a squared, I think I'm going to start having some repetition. When I plug in 1, I get 2. When I plug in 2, I get 4/5. So now I can come through here and plot these points. -2 is 4/5, so that's just a little less than 1. -1 is 2. 0 is 4. 1 is 2. 2 is 4/5. And I know this is an asymptote, so it's going to approach the asymptote but never reach it. The graph goes up, comes back down, and that's what it looks like. Yes, sir. The question by Ty Thornton, say hi, Ty, was how do I know that it's an asymptote? And it's an asymptote because this is part of the definition. If the degree of the numerator, the top, is less than the degree of the denominator, the bottom, I have an asymptote of y equals 0 plus a shift if there's a shift. There's no shift here. There's nothing added on out here, so there's no shift. So then it has to be at y equals 0. That's part of this form. I'm telling you to memorize that. Okay, and that's why it's on the sheet in front of you that I gave to you. Okay? Questions on graphing this particular graph or this kind of graph? Yes, Mr. Garrett. You plug it in the calculator, it looks a lot different. Uh-oh. Let me see what you have. Excuse me, I'm going to pause for station identification as Garrett proves me wrong. So Garrett was plugging this into his calculator and trying to double check my work, which isn't a bad thing. What he remembered and realized, and we needed to point out, is when you plug this to your calculator, if you do 4 divided by x squared plus 1, in my calculator, it doesn't know to put this together unless you put a parenthesis. You will come up with the wrong graph if you make that mistake. Thank you for teaching us that, Mr. Garrett. Appreciate it. Let's try a different one. My next example on the note sheet that I gave you, this is letter C. This is letter C. The degree of my numerator and my denominator, the top and the bottom, are the same. They're both 2. So my vertical asymptote is located where the denominator is equal to 0. That never changes. My horizontal asymptote is, again, just like last night, this ratio of 3 over 1 plus or minus any shift that might be in there. If it's a positive k, it's going to shift it up. If it's a negative k, it's going to move it down. But that shift is going to move things around a little bit. So let's see what happens. So my m and n are the same. So my horizontal asymptote is y equals 3 over 1, or 3. There is no shift. There's no k on it. So there's nothing else that's going to move it up and down. So I have a horizontal asymptote at 3. Y equals 3. At the same time, I can talk about my vertical asymptote. My vertical asymptote is when my denominator is equal to 0. So x squared is equal to 4. So x is equal to, trick question. And we wait in silence. And see, Mr. Jimmer Jaden Dean, when he hears this video in 30 years, says, I forgot Mr. Alonzo was calling me Jimmer. See, he says 2, and he's right, because 2 times 2 is 4. But what's the other answer? It needs to be plus or minus, because negative 2 is also an answer, which tells me that for this particular problem, I actually have not 1, but 2 vertical asymptotes. One at x equals 2, and one at x equals negative 2. Now, before we go on, here's the question. Make sure you're listening. This type of problem, am I going to really ask you to do this without your calculator? Most probably not. But I do want you to see kind of what we're doing here. Since I have my graph now is broken up into about 3 regions. I'm going to have 3 different pictures. Technically, it's broken up into 6 regions. But my graph is going to be broken up into 3 different parts. If you were to graph this, if I was to pick x and y points, and I can do that if you need to see that, this graph actually will look like this. Okay? How do I know? Well, what I would need to do is I would need to pick x's that are in the different regions. I could pick negative 4 and negative 5. I could pick 1, 0, and negative 1. I could pick 3 and 4. That should be 3 and negative 4 and negative 3. And I can plug these in, and I would be able to see where this graph is. Since I'm going to ask this type of question with your calculator, I'm not going to kill you by having you do all these by hand. But I need you to get the understanding that if needed, you could do this by hand. The asymptotes is what's important. What else is important? You need to know your domain and your range. What x's can I pick here? X is an element of all real numbers except positive or negative 2. Forgive my board running out of space. My range is y is an element of all real numbers except 3. And those come from the asymptotes. And this is how I get every other number. I get every other number because my graph is actually broken up into 1, 2, 3 parts. Remember, we're still calling this a function. So if this is indeed a function, I can't have another part of my graph here because it fails my vertical line test. So that's how I know that it's going to be in 3 different regions. Even though there's 1, 2, 3, 4, 5, 6 different parts, I can't have any overlap horizontally. Excuse me, vertically. Okay? Any questions on this type of problem? My last type of problem, it's kind of the point where at this point, all bets are off. When my degree of the top variable in the numerator is larger than the degree in the bottom, the denominator, there is no horizontal asymptote. It might look like there is. There might even look like it's some sort of an angular asymptote. You could have a graph that looks something like this with these. And again, that's why we use our calculator for these. I'm not going to kill you in this class to do these by hand, but you need to understand what it looks like. For this particular problem, all I need to worry about is a vertical asymptote. So again, x plus 4 is equal to 0, so x equals negative 4. I have a vertical asymptote at x equals negative 4. Can I go ahead and pick x and y's and put this and figure out what this is? Sure. More than likely, can I plug this into my calculator and see what it looks like? Yes. If you actually graph this one, it's going to look something like this. And I kind of put a few extra curves in there. But the point is, I need to know what the asymptote is doing. I need to know what my domain and my range are doing. So what's my domain? X is an element of all real numbers except negative 4. What's my range? It's all real numbers. Is that what you were saying, Garrett? Yes. There's no limitation to my y's. Pause for stationary identification. So one thing I normally don't do on videos that I'm doing for this one is I'm actually giving your homework. Your homework is on page 550 through 551. Numbers, don't get upset, 20 to 31. 12 problems. All of them, well, the first 5 or 6 are graphing. Are matching. The rest are graphing. Graph paper would be nice. If you are watching this at home, please, 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 please make sure to use graph paper and show me the homework from the night before, because what everyone doesn't know is I haven't graded it yet, but I'm going to grade it for them right now. So as they start working on this, the rest of you, hopefully you did well on your AP test, and we'll be saying goodbye. Say goodbye.